So here we're kind of seeing a little bit of the process in a MBD environment. So our designers create, for instance, here we've got a a private jet. In the designs and the individual parts of that private jet, we're adding our PMI. And that product, as identified by that down arrow that you can see there, that would be our output to, whether it's to our suppliers, whether it be to our OEM that we are creating product for, or whether it be to a manufacturing shop that is going to create the different parts for us. Long gone are going to be the days of needing to have several GD&T experts on staff. Included in the ecosystem and with MBD in NX is the PMI Advisor. And I'm going to step back a minute and mention something very important. MBD is not just a Siemens thing. MBD is being driven by the Department of Defense, by the OEMs, by the automotive industry, and within the Siemens portfolio, we're able to import and use PMI and model-based definition from any system. And I think that's important to mention that, this is not a, I'll just leave it at saying that within the Siemens ecosystem, we can use and leverage everyone's PMI. So yes, and anyway, included with that is once we go into the step of the PMI Advisor, what it's going to do is it's actually a digital GD&T expert, and you can quickly run an analysis, and it will tell you if there's a problem with your PMI, which is essentially like looking at what used to be a 2D drawing. And it's important to mention here that from the PMI, so just to take you kind of through the process, your engineers will add PMI to your models. That PMI will be checked by the PMI Advisor, and then you can use that information in CAE for setting up, whether it be a CFD analysis, whether it be an FEA analysis, whether it be a multi-physics analysis. And then two of my favorite tools that leverage MBD are NX VSA, or stack-up analysis. So in the instance of this aircraft here, you've got a flap on the wing, or let's use the elevator. You've got an aerodynamic surface that is connected via links to some hydraulics and to a control system, and we'll say just for old-fashioned sake that there's cables. What VSA will do is it will look at the manufacturing tolerances of every single link between the pilot's hands to the yoke and all of the links that follow back to the flight control surface. And using the future control frames, using all of those tolerances, it will actually exercise your assembly and show you how much hysteresis, how much deviation there might be from the neutral position of that flight control surface to its extrema based on the tolerances. And so gone are the days. I mean, I worked for a company that had an Excel spreadsheet back in 2011 in which every single tolerance was put into this spreadsheet, and it was kind of like a matrix, and you would have to highlight column A and which component you want to start from and go all the way down to identify the how much stack up and how much deviation you may have.